Good day, everybody. Pete Will here. We're going to just wait 1 minute for people to get logged on. Those of you that have already logged on, please just stand by. We'll start in 1 minute. All right, I think that's good. Thank you for your patience and good day, and welcome to today's webinar entitled Mineral Exploration Using ArcGIS. My name is Pete Will. I'm an account manager on ESRI's Natural Resources team, and my primary focus is business development for the mining industry. I'm talking with you today from Erie, Colorado, and I'm also emceeing today's webinar. This webinar was organized in collaboration with the ESRI Mining User Group. And a recording of this webinar will be posted on YouTube and shared with all registrants. Throughout the webinar, we encourage you to ask questions through the GoToWebinar question dialog box. We will try to answer as many questions as possible at the end of the webinar, but any questions we don't get to will be answered in a follow-up email and sent to all registrants. All right, I'm joined today by Matt Ballard and Fernando Lopez. Matt's joining us from San Antonio, Texas. He's an solution engineer and my teammate on the Natural Resources team. Fernando's joining us from Toronto, Canada, and he's the Director of Geoinformation and Analytics at Alamos Gold. Before beginning, I'd like to say a few quick words about the ESRI Mining User Group, or affectionately known as the MUG. The MUG serves several purposes. First, it acts as a professional networking organization focused on geospatial professionals in the mining industry. ESRI is very committed to understanding what's important to our mining customers, and the MUG acts as our community outreach site. It's how ESRI gains feedback from our users. The MUG also works to coordinate seminars and networking events at mining conferences and facilitates webinars like this one. These webinars are designed to document and demonstrate mining workflows, which leverage geospatial technology. And the MUG has been in existence now for 12 years. It's made up of over 2,000 members. The membership is managed on LinkedIn, and I strongly encourage you to participate and to join our community. Okay, with that, let's take a look at today's agenda. In today's webinar, we'll be discussing approaches for bringing digital workflows into mineral exploration with the goal of providing improved operational efficiency and decision making. First, I'll provide an overview of the ArcGIS system. The ArcGIS system may be familiar to those of you who have joined us in previous webinars and use ArcGIS regularly, but I feel it's important to review. There has been new updates, and a quick review will be valuable to all. Following my introduction, Fernando will provide an overview of how to track the progress and results from the drilling phase of your exploration program. His presentation includes new ways to use ArcGIS dashboard, and I'm excited that he's sharing his use case with us. And then Matt Ballard will demo some ESRI technology that should provide some food for thought on how ArcGIS and digital workflows can be used during the pre-drilling field data collection phase of your exploration program. And then finally, we'll wrap up with a question and answer session. So with that, let's go ahead and dive in. So this slide reminds me of my days as a exploration geoscientist. I'd spend the field season collecting data, compiling it back in the office, updating my exploration maps, and then gathering around a table to present the results to my management. This is still done today, and the goal of the exploration geoscientist hasn't really changed. But what has changed is that there are now new digital options available related to how we collect, compile, and share our results to the businesses. By using a modern digital approach, we can prevent valuable data from being corrupted or lost. We allow for much quicker data-driven decisions, and we effectively create a digital twin of our field program. And then ultimately, we save time and money by providing better control over the exploration budget. So today, there's lots of opportunities to use digital and spatially enabled workflows. And this webinar is geared to introduce you to some of the tools available through the ArcGIS system. The ArcGIS system is a group of commonly developed applications that link all aspects of data analysis, management, and collaboration. From desktop to field apps to WebGIS, the ArcGIS system provides the geoscientists with all the tools they need to efficiently find that next economic resource. Here's an old slide of a deployment pattern for ArcGIS that I use when I'm presenting to exploration companies. Many companies still work this way, and the workflow is still very relevant. This workflow includes the exploration geoscientist using ArcGIS desktop in a disconnected mode, while still plugging into corporate enterprise systems in a connected fashion. This allows for access to corporate information and the ability to deliver project updates. This approach allows for independent offline usage, but also captures that new data for corporate use. Today, digital workflows have advanced. I think we could agree that we've all become more comfortable with connected system and have somewhat of an expectation that most staff will always be connected. While this is true and facilitates many styles of work and workflows, it's important to remember that in certain situations, including exploration, we need to be able to operate in a somewhat of a disconnected mode as well. I think we can all agree that there's tremendous advantages to being connected. There's the access to increased processing capabilities and large amounts of data. There's also integration with critical business systems. And most importantly, the ability to connect with colleagues. And in my opinion, the digital transformation we are seeing in mineral exploration has changed it for the good. This digital transformation provides the explorationist with advanced digital tools while addressing their need to work in a disconnected mode in the field, and all the while providing a flexible and scalable solution in order to service small and large companies alike. So before we move on to the demonstrations, let's first do a quick little review, remind everyone of the ArcGIS common patterns of use that we've discussed in previous webinars and many of you will be familiar with. These common patterns of use represent the diverse capabilities of the ArcGIS system. And in both of today's demonstrations, you'll see examples of how each of these patterns play an important role in satisfying the specific workflow they are addressing. Today, we're talking about exploration workflows, and we're going to focus in on mapping and visualization, data management, field mobility, design and planning, decision support, and then sharing collaboration. So throughout the demonstrations, look for examples of where these come into play and how they're put into practice I think you'll see examples of each in the demonstrations. The ArcGIS system has a role to play across the mining life cycle, and our focus today is on exploration workflows. These include, but aren't limited to, geologic mapping, planning your drill programs and tracking the progress, field data collection, and very much the management of the significant amount of data that is coming in associated with these activities. And in closing, if the ArcGIS system is applied from the first permitting activities to the final mine closure, you'll be assured to have a dynamic and digital atlas of your project's data, allowing key stakeholders and team members to browse, search, and discover your geo-enabled data. So with that, I'd like to reintroduce Fernando Lopez and give Fernando another opportunity to introduce himself in greater detail and share with us his use case. So Sarah, will you transfer that over to Fernando, and once we get him up and running, we'll turn the floor over to you. And we see your screen, Fernando, so the floor is yours.
Thank you very much, Pete. Well, thank you very much again for the introduction. My name is Fernando Lopez. I work for Alamos Gold. Alamos Gold is a mining company, a gold mining company with operations mainly in North America. My job is very simple to describe, but actually quite difficult to do. It is to manage all the exploration data for the company. So let's take a look at where we are. When I joined the company, we only had one operation in Mexico. It's called Mulatos. But now through the years, we've acquired and merged with other companies, and now we have 3 main operations. However, what we do, or what my team does, is to manage the exploration data, and these are the location of our projects. The presentation I'm going to give you today, it was already given in 2020 as part of the MAG meeting right before Playback. So if you were there, you probably already saw this. And today I'm going to show you 2 cases of how to use your ESRI dashboards. Anyways, let's go back to the presentation. These are the projects. However, what I see, and I always tell people this, what I see is data. So every single of these projects, they produce data, whether they create new information, collect new data, or they purchase information. For example, a new geophysical data set. So to me and my team, what we see, in fact, is just these gigabytes and terabytes that are coming from site. And our job is to make sure that everything gets properly managed. And when I say properly managed, I mean, I'm talking about the workflows, I'm talking about the storage of the data set, and finally, I'm talking about the distribution of data, which is also extremely important. Everyone should have live access to the information. I put together this slide a few years ago just to show how the information was piling up for one of our projects. And although it is not related to one of the projects now, it just shows how the information goes up with time. The information never gets stuck. It never stops growing. We always receive more and more information. And it is not that you're not going to stop using the historical or legacy information. You also have to manage that. So this slide is just to show you that information, it's always evolving, it's always growing, and you need to make sure that the system that you're managing is able to escalate and manage that new information that might be coming in 2 or 3 years. An example of what we manage, and by the way, this is a web map. This is an ESRI web map. This is showing the color information, the lithology information, and we also have access to all the information that it is required by site. A note here that all the information from the field is collected using collector. We included photos, lithology, structures, and so on, and the information flows through our system and gets stored in the database or in the geodatabase. Another note here is that our core system is SQL. All the information, including the spatial data sets, they go into SQL. Now, but just to look at this into more detail, what we store in the GIS system is remote satellite images. For example, what we're looking at right now is a 0.5 meter resolution worldview one, and we have several of these ones, which could be quite heavy. For anyone who's been managing or working with satellite images, you know that this is really, this could be very large data sets. The second one that we manage is also your physics. As well, it could be legacy or new projects that come up with a new data sets, and everything goes into the same system. We also have these, and I really like these maps. If you pay attention to this slide, you will see that there are these two different colors here. The intense color polygons, this one here, they are collected using collector, and the ones around are the interpretation made by the geologists in the office. So these two data sets, or these two layers, they go into the system as well, and they evolve, they grow, and by now, obviously, we have way more data than before. Another thing that we manage, and this is a combination of non-spatial and spatial data set, is the colors. So every single color that or every single drill hole that the company drills goes into the system. In this example, the black dots are completed holes, the blue ones are planned, and the green ones are abandoned. But we were missing one data set. And I think we were missing it because it wasn't considered to be a geological data set. This is the drilling reports, or the ship reports. So that information was left on paper, and sometimes were put in Excel, but everything was a manual process. So when we asked about this information, it was very difficult to get an answer. It was very difficult to get a statistic of this data set. So 2 years ago, or maybe 3 years ago, we started working on this project, how to capture this information and how to show it. I'm pretty sure everyone on this call has seen this before. I'm pretty sure everyone manages their information, the geological information, very well. So you can, nowadays, you can just put together all your geology, your core photos, your assets, everything in one single place. But it hasn't been until recently that companies have started realizing that the drilling data set is actually quite important as well. And it is important because at the end of the day, that component is probably the one that takes most of your budget. So we needed to find a solution to track and monitor that information. Okay, so we started with a simple question, and the question was, how much do we drill? And if you ask this question to if you ask this question in the past to two different people in the same project, you might have two different answers. And you might have two different answers because everything was in paper, or everything was in Excel, or there was no workflow set up to manage this information. Okay, let me apologize about this slide. It's my way to say that we needed to quantify this information. Okay, so we started with the requirements. And when it comes to requirements, there are two types of requirements. The first one is the user's requirements, and the second one is the data requirements. Let's start with the first one, user requirements. So when you started asking people what they would like to see, the very first question was a very easy way to see the total number of meters that we drill. So we call it the totals, something like that. The second one was they wanted to see what companies have been drilling in the property. And not only that, they wanted to see what machine was drilling on what property. So the examples that you see on the slide right now show you a very common contractor, driller contractor, and the one at the bottom will show you the different rigs owned by this contractor. So they wanted to see something like this. This actually came from my side. I wanted to see the behavior of the drilling through the time. So we have monthly graphics, like the one on the top, and then daily graphics. This helps me understand if, or see if there is a gap in the information. And if there is a gap, it might be related to an issue. So we can identify those ones. We also wanted to see the information is split by different satellite projects. And you can change the name here from a project to a prospect. So we wanted to see the information split by prospects. And also the type of information, the type of drilling. It is whether DDH or RC. And this was a very interesting one because people were recorded the information of mixed holes as just one single entity. But with this system that we put together, now we were able to split this information into DDH and RC and reported it accordingly. And one more thing, what geologists always want is the spatial component. It doesn't matter how good your tables are, your reports, or your charts. They will always want to see a map. So we had to include this spatial component. And this is, again, similar to the one before. It was just a color map. So if we combine all of this, we came up with this. So this is what we were working towards. So a single interface that shows your map, shows your totals, and shows any type of graphic that you or they require. So the data requirements to get to that point. The image here is showing you every single column that goes into the creation of that data dashboard. So the columns in green are basically every single column that you're probably already capturing. The ones in yellow and blue, those are calculated fields that we needed to create in the database to provide the information that we needed to create this dashboard. So for example, the ones in yellow, they are very simple. They only split information by type. So DH versus RC. And the ones on the right-hand side, the blue ones, they split the drilling date into 4 different categories or 4 different columns to make it easier for you to create your graphics. We also put all of this information, every single of these columns, into one single SQL view because we also wanted to export the information if it was necessary. So the workflow to create a dashboard, it involves more than just working with your software. It also involves going to site and doing these 3 things. The first one is the drilling part. Well, we don't do the drilling part, but that's done by the contractor. The next day, the driller report arrives at the office, has to be approved by someone, by the exploration manager or the project geologist. And then the next step is to get that information into the database. And here is where we really struggle to convince people to enter this information. So this is a change management problem. So you need to get the buy-in from the exploration manager or the director of exploration or anyone high up in the organization that just tells staff that this has to happen. Otherwise, it will never happen. Now, for example, every single day or most of the days, I will tell you an example later, most of the days we receive the driller reports, technicians enter the information to the database, and from that point onwards, our systems take over. The first system is an ETL system, SSIS, which is SQL basically. And that pushes the information or combines the information that you capture here with the colors and produces one single table, a spatial table with all the information. Minutes after this happened, this second system takes over and publishes the information to ArcGIS Online, to our own site. And this is how we get information from drilling into the cloud every 12 hours. So to build a dashboard is actually quite simple. Once you get to that point, your information is going to look like this. It's going to be one single entity into your ArcGIS Online. It is called a feature layer, a hosted feature layer. Once you have it there, you can create the second one, which is a dashboard. This is the interface. And all you need to do is to connect this interface to this dataset. Once you are there, all you need to do is to create all these different, I think they are called widgets, and someone can correct me if I'm wrong. Creating these widgets is extremely simple. And I usually tell this to people. Creating a dashboard in ESRI will take you less than a day. Preparing the information, preparing the workflows, convincing people, and answering all the questions that need to be answered can take you up to months. So it is not as simple as just opening the dashboard and start creating things. You need to change many things in the organization. So this is our index map. So our geologists and users go to this map and just click on the project they are interested in. So in this case, it is the one in Mexico. You go to the drilling link, and this is what they see. It is the dashboard, and again, this is refreshed every 12 hours. But this is not enough. They also wanted to see some type of filters, some type of sectioning in your database. And this could be achieved by using these filters. So you can create any filters that you want as long as they exist in your tables. Once you create the filters, you connect these filters to each of these widgets and it will work. So for example, in this case, I'm just looking at February. What happened in February? We only drill in that area, 19 holes, 1,400 meters, and then you can see it also by date. So why do I call this a data story? It is a data story because we've gone through a few different systems to get where we are. The first one, and again, I joined the company in 2014. This is what I found. People were still using paper. We're still using these documents to report the drilling. And as you can imagine, doing this manually, it's not only it takes time, but also it creates confusion and can insert errors into the information. So this was the very first system that we had. The second one, and I'm pretty sure many people in this call don't like Excel, including myself. Excel came up with these tools called pivot charts and pivot tables. So I actually went back to use Excel after I knew that functionality existed. So as long as your data is not stored in Excel, you can connect Excel to your SQL database and still have a very simple way to visualize information. But again, it wasn't enough. So the next system that we tried was ESRI. I'm not sure if many people play with this, but ESRI had a previous version of the dashboard. It was called Operations Dashboard. And we also used it for a while. But we knew that a new version was coming, so we didn't really develop it much. The next tool that we used was Power BI. This is a Power BI. And the only problem, well, I had only two problems with Power BI. The first one was that it wasn't part of our IT software suite, meaning that we had to buy all the licenses. And the second issue I had was that it doesn't work with UTM coordinates. So if you want to move the map, it has to be in geographical, which is not a very difficult problem. You can just transform the information. But anyways, that's Power BI. But we decided to just continue building on our ESRI technology. And now this is what we have. A very important thing about the dashboard is this, the date. Because many people go into the dashboard and they need to be aware when was about the last update date. Otherwise, they will be looking at historic information. So why are we using our this ESRI technology? Well, it fits our current technology. We're already using web maps. We're using ArcGIS Pro. We're using Collector. We're using Survey 123. It was very easy to integrate. So we didn't have to do any much data transformation. The second one, it provides global access. So it doesn't matter where you are. You can be on vacation in Hawaii or wherever. Go into the website, open your dashboard and see information. And again, this information gets updated every 12 hours. And finally, the low cost. If you already have an ArcGIS Pro account, an ArcGIS online account, the dashboard is essentially free. The only thing you need to be concerned about is the space that you need in your ArcGIS online account to store this. But again, it is not very expensive, and I'm pretty sure Pete can speak about this. So what is next? Again, I made this presentation a year ago, and now we're already there. So what was next? So create more dashboards, essentially. And the second one that we wanted to work with was we wanted to answer the questions, how many photos are we capturing every day at our different sites? Since we only use one single tool, which is called Imago, I'm pretty sure many people are using that tool to capture photos. We just needed to connect to that system and extract the information to show it in a simple way. And this is what we came up with. But to get to this point, you need two things. Oh, well, you need a couple of scripts. And it was really good to see that ArcGIS Online came up with the Jupyter notebooks, and also that you can actually schedule this to run on demand. So for example, this is the very first script that we created. And this brings all the information into our account, into our ArcGIS Online account. And the second one, it actually does a QAQC And this is how we get an error account of our data sets. So now we not only have one drilling we not only have one dashboard, we actually have two dashboards using the same technology, but configured in two completely different ways. The first one, all the information comes directly from SQL in our servers, and the second one, it actually comes from the cloud, from someone else's system. And that's it. Essentially, that's it, Pete. So if anyone has any questions, or now or later, I'll be more than happy to answer.
Yes, and thank you so much, Fernando. That was great, and I know it's going to drive a lot of good conversation. I will reiterate what Fernando just said. If there are questions related to what Fernando just presented, please drop them in the question dialog box, and we'll try to get to as many as we can. And I think we're going to turn it over to Matt Ballard. Matt,
yeah,
do you have the screen? Yep. All right, perfect. And Matt, please give yourself a little bit more of a detailed introduction than I did at the beginning, and take it away. Floor is yours.
Yeah, thanks, Pete, and thank you, Fernando, for that great presentation. Like Pete said, my name is Matt Ballard. I'm a solution engineer on the natural resources team, and so we walked through a couple of demos of looking at some of our data collection technology for exploration workflows. Fernando showed some really great examples around data management and integrations and visualization. And so, and even he mentioned an example of where they're actually collecting data out in the field and doing interpretation on that data. So I want to focus really on that data collection component. And in particular, we'll be talking today about ArcGIS field maps for a good amount of the time. So ArcGIS field maps, as a quick introduction, is ESRI's primary field mapping application. For those of you who've used applications like Collector and Explorer, we're combining those applications into a single streamlined application. We'll be including, at the moment, we have Collector, Explorer, and Tracker out there, and this is available for you to use today. And we'll also be adding in applications like Workforce and Navigator, with the ultimate goal of simplifying deploying applications and improving the user experience. So today, again, the focus is on some new features in ArcGIS field maps, as well as ArcGIS Pro and how that fits into the field data collection workflows. Really, everything starts with Pro, though, which is where I'm going to start by sharing my screen. Pro is where you're able to create data models and author maps for data collection. So I've got this map here for Pedernales Falls State Park in the Texas Hill Country. This area is primarily characterized by Cretaceous era sedimentary deposits of sand, gravel, and limestone. And you'll find some outcrops, which you'll see some pictures of, where there's some angular inconformities, where the Cretaceous deposits overlay some tilted Pennsylvanian limestone formations below. And so the idea is, we want to go out there and characterize this area with what we know. So I've built my map. I've got layers to collect data into for things like, on the left side, ecology, things like wildlife observations in wetlands areas. I've got cultural data, like roads, boundaries, and then geologic data, of course, which is the most important here. Information for outcrops, drill collars, rock observations and samples, and more. Now, from Pro, the first thing I really need to do is to bring this into ArcGIS field maps is share it. So from the top, I can press share and share web map. Upon sharing this, I'll be able to access it from my ArcGIS organization. And so I'm going to jump over to my web browser where I've already packaged up and shared that map. And this is where you're able to do a little bit of extra configuration for field maps before bringing your maps out into the field. With ArcGIS field maps, you have access to an application that's in the top right here in your app launcher. And this takes you to, again, an authoring environment for these maps. First thing you'll find is all of the maps that you own, and we can open up, for example, the one that we just published a second ago from ArcGIS Pro. Give this a second to refresh here. Okay, so here are all of my maps, and I can click on each of these to launch into them. And on the home page for my map, I first get some general information, like who owns it, when it was created, its offline status, how it's shared. And what's new to this application that you've got is the ability to actually open this map up directly within the Field Maps app. So historically, you might have had to bounce around between the map viewer to configure your map, then you'd have to go view it on your mobile device to see what it looks like in the field. But now I can open this directly here within the single application. So making it ultimately a lot easier for you to build your maps before going into the field. One thing that I might want to do with this map is change the order of the layers. So geologic data right now is appearing below the ecology data. So I could simply just move this group layer. And because we're using the new map viewer, I'm able to move groups of layers as opposed to having them each independent. So it's helpful for organizing your data, and you'll see these group layers work in the field, but also for just better organization. And with that change done, I'll just go ahead and save that and go back into Field Maps. Now, the second thing that you can do within this environment, aside from editing your map, is configure feature templates and smart forms. So some of you may be familiar with the smart form features in Survey 123. What we're doing is adding some of those capabilities for smart forms into Field Maps. Not necessarily any plans to replace Survey 123, but just taking what's really good and what users like in that application and bringing it into Field Maps. For example, the geologic rock observations and samples form, I can click on that one and go up to the smart form option here at the top, and I can start to build my form. First, I'll start off by adding a group. A group can help you organize certain elements. For example, I know there's some fields in here for capturing some rock characteristics. And I can go select those. So things like the class composition, rounding, size, sorting, and more can all be dragged right into that group. And I can also grab just a couple of other elements within here. For example, the rock type. I'm going to put that up at the top. And then I can add another group as well for, I see there's some information about whether a sample is taken, what that sample number is. So I'll put those down here in this second group. Okay. So grouping is the first smart form feature that's helpful for organizing, again, the questions of your form. The second one that we'll talk about here is the ability to change how people provide inputs. So I know this rock type question has a pick list in it, and so I can change that to appear as radio buttons, for example, so people can see all of the options without having to click the drop down. And then I'll go ahead and change this. I know we're working with mostly sedimentary rocks, so I'm going to put a different display name in here. So I'm able to, again, configure it without having to go change the actual data layer, the actual database. And the last smart form feature that I'll show you is conditional visibility. So some of these questions are only relevant depending on what sedimentary rock type I select. If it's clastic, then I want to ask information about the clast composition. If it is a chemical sedimentary rock, then I want to ask for information about the composition instead. And so, for example, rounding, if I select that field and go to the bottom right and add an expression, I can say only ask this question or show this question if it's relevant when the rock type is equal to clastic. And I've already gone ahead and finished the rest of this form over in the second tab. And so I'm just going to show you what this looks like here. So we finished configuring it, and we can go preview the form. So these smart forms work in the map viewer, which means you're able to test them again all through this Field Maps application. I'll edit the map and add a new feature for our rock observation samples. If I choose caustic, I get information or questions corresponding to that. If I choose chemical, I get different questions. And I've got these different groupings and more conditional visibility. All right, so that all looks good. The map looks good. My forms are configured. And the last thing that we would do within this Field Maps application is configure offline mode. So we're going to get out into the field in a place where I don't have internet connection. So I need to prepare this to actually collect out there. To do that, I can ensure that each of my layers are enabled for offline mode. So they've got the green check. And if there's any issue layers, then I'd be able to fix that from here. And then I can build these pre-planned map areas. Pre-planned map areas let you package up areas for offline usage. It'll take the base map, it'll take all of your different layers and put it into a single item that can be downloaded from ArcGIS Field Maps. All you need to do is drag a box around your area of interest, specify a level of detail for the base map, and then optionally, if your map needs to update on a regular basis, such as every day, every week, every month, you can configure that so that way users always have the most up-to-date offline map available with recent data. Now, I've already created one of these, so we can transfer over to my mobile device and see what that looks like. Right, let's see. Okay, so I've switched over to my mobile device and about to launch ArcGIS Field Maps here. From ArcGIS Field Maps, I'm able to access all of the different maps that are available currently while I'm online. And then from here, in these online maps, I'm also able to create a new offline area on demand. So if I'm working out in the field and I didn't get a chance to pre-plan my workflows, I can still create these offline areas on the fly. So you'll see I just click add offline area there, specify my area of interest and the level of detail again. Now, in this case, again, we saw that I created one earlier, and so I can go ahead and download that one to work with on my device. So those offline maps appear here, and you can see the size and when it was last downloaded, and I can start to work with that. As I mentioned earlier, ArcGIS Field Maps, it supports the ability to have these group layers. So you can see the ecology layers, culture, and geology layers separated by those groupings, helpful for organizing and navigating through the map. Now I'm going to switch over to a recording from when I was actually out in the field offline. And since I'm remote, the first thing I really need to do is actually connect to a GNSS receiver. So this GNSS receiver will give me my location accuracy. I'm using an EOS system, and I can specify that antenna height. And we can start to collect using those smart forms that we built earlier. The first thing I'm going to collect, though, is some strike and dip information for an outcrop that we observed. We can take a picture of that. And the second thing that we'll collect with is that smart form that we built for the rock samples and observations form. So again, at the bottom right, click the plus sign. I've got all my different feature templates, and we'll select that rock observation one and take a picture. So with this specific rock, going through our form, it's clastic rock, so we'll select that from our dropdown. In this case, it's all appeared at the front because we use those radio button options in the configuration. If I switch to chemical, I get different questions, right, subsequently. And we can start to fill out the forms. We'll say some of the classes appear to be quartz. They appear to be just rounded. And then we also have pick lists for things like sorting. Say it's well sorted and it's primarily cobble sized. And then the last thing we can do here is just provide, classification. So all this data is being captured offline. Once I'm ready to sync this back up to my my central ArcGIS organization, all I need to do is connect to the internet, press sync, and all of the data that we've collected will be sent back into those feature services. All right. Now, the last thing that we'll sort of discuss here is, is ArcGIS Pro. So ArcGIS Pro is another tool that can be used for collecting data. We've really focused on ArcGIS Field Maps, which is on a mobile device, right? It's on a tablet or a phone. But there are scenarios where ArcGIS Pro can be used for data collection. You might be working remote for many days offline in a disconnected environment, or you might have more complex mapping needs than what you can get with field maps. And so back in Pro, I just want to show you a new feature that we've added, which is the ability to connect to a GNSS receiver, like this Arrow Gold device that I'll be using. While out in the field, I observed this structure that I wanted to collect the boundary of. So within Pro, I'm able to connect to my, my GNSS device via Bluetooth to actually drop accurate locations around the boundary of the structure. So I'll connect to that Arrow Gold device all through the ArcGIS Pro settings and device settings for Bluetooth. And what this will do is start to stream that GNSS position into Pro, and we can start to use it for editing. So I'll just, again, configure my connection here. And in the interest of time, I might skip forward just a second. And here I can see that location now where I am out in the field, completely disconnected using my laptop environment. I can see my heading, current location, and a number of details on the right side. So on the right side, you can see things like my accuracy, my dilution precision. You can see the satellite locations and strengths, and you can even log data to a metadata file. To do editing with this information, you can see I've got about 0.5 meter resolution or 0.5 meter horizontal accuracy, so I can get some pretty good data collection. And to actually do the editing, I can use all of the out-of-the-box tools in ArcGIS Pro for collecting data. So all I have to do is go create a new polygon feature and drop a point at each corner as I walk around the structure. At the bottom, I've got tools to drop points as I need to. So it's this little blue pinpoint with the plus sign. And so as I reach each and every corner, what I'll do is just drop a pin and continue to drop pins as I walk around the entire structure. So whether you're needing to collect data in a mobile device or on a tablet in sort of that smart form, easy to use mobile application, or if your needs are maybe a little bit more complex, you can use ArcGIS Pro. Really, either way, the tools are there for you to collect data in the field. To wrap all of this up though, I want to talk about another new feature that we've been building that's going to be helpful for viewing data you collect out in the field. While out in the field, I collected a number of pictures, things like just pictures of outcrops, pictures of different rocks that I observed, and more. If I want to see all of these on the map, all of these pictures have metadata in them that tell me the location where they were captured. So we can take those GPS metadata and put them onto a map. And so here I've jumped over to another map, and what we've built is a new toolbox for managing what we'll call oriented imagery. So all these just standard pictures that I've got on my phone, for example. These tools allow you to create maps like the one that you see here, where each of these green dots represents an exposure point where the picture is taken, and the triangular shapes represent the direction that the camera is looking. This is one of the tools to add images to this. It's called an oriented imagery catalog, and it supports imagery of all types, things like aerial, drone, indoor pictures, terrestrials, panoramas, 360, and more. And what I can do now that I have it on my map is I can select anywhere where we know there's a picture that's been taken, and it'll show me the picture at that specific location. So here's a picture of that outcrop that we observed. I can zoom in on it. I can see it updating the specific area that I'm looking. And it's time enabled. So I went back at a later date and I annotated that picture to provide some details based on what we talked about earlier, the geology out here. So layering and labeling this angular unconformity. And as I jump around, I can see all the different pictures at each of these different locations. This entire oriented imagery catalog that we're using here within ArcGIS Pro can also be shared. So taking the map that we've just built, taking the data that we collected in the field, right, and the oriented imagery viewer that we built in ArcGIS Pro, we can now layer it all in here together in a web application. As I click around, I have access to all of the different pictures again, just like we had a second ago. And I can even click on things like our rock sample that we observed. So we can see the data that we collected and the picture attachment of that specific rock, and all in conjunction with this oriented imagery. Taking this even a step further, you can start to bring in drone imagery into an application like this and visualize this data in 3D. Here, using just satellite imagery in this case, we can see the 3D terrain of this specific location in a 3D field of view for the picture that was taken. And you can even start to see, even within the satellite mesh here, you can start to see that angular unconformity and see how it is more of like a flat surface over here. And so you can see where those two formations meet. And this picture provides some additional context, of course. So you can imagine then the next step would be, if we fly a drone around here, each of those pictures represents another source of data that you can put into this oriented imagery catalog. You could start to get very high resolution photorealistic visualizations of the field out here and use it for interpretation use cases, all in conjunction with the data that you've collected using ArcGIS field maps and ArcGIS Pro. So with that, I'm going to pass it back over to Pete before our question and answer session. And yeah, thank you, everybody.
Yeah, thank you, Matt. Appreciate that. And again, great stuff. I know I can, judging from the questions that are coming in, it's generating a lot of curiosity and good conversation. So we do have a lot of questions that came in, some of them on the technical side. So I just want to remind everybody that the questions will be compiled and summarized and sent to everyone. I can see where Fernando's been answering some directly. So we won't get to all of them, but let's go ahead and dive into the questions and see what we can get done. Matt, real quick, can you confirm you see my thank you and question slide?
Yes, it's up. Got it.
Perfect. So maybe we'll start with Fernando, and this is a kind of a high level question to Fernando, but one I get quite often when talking to my customers is how do I drive adoption? So I'll go ahead and read it as it came in. Oh yes, and Fernando, all of the questions to you start with great job. So you should be proud of that. Fernando, your systems and dashboards look great. What kind of process did you use to get people, i.e. non-GIS users, actively using them. And then Maggie cites that we've implemented similar dashboards for the exploration. GIS team loves them. Most managers just want screenshots. Any tips? So maybe from a high level, how did you roll this out?
I think the easy answer would be to create the need for dashboards or any other application. If the need exists, they will end up using it. Now, to answer this in more detail, the first one is to get your buy-in from upper executives. If they see the value in this, then they will just filter it down to the different sites. The second one is to work on your change management strategy. If you go to site, if you help people, if you show them that whatever they are doing is taking some time, and then you can reduce that by hours, then they will adopt it.
Excellent, thank you. And again, I think that's where the conversation should start, is the need, and then going ahead and getting buy-in and then pushing it out to your users. Fernando, this one's to you as well. I think these are kind of tie in what Matt showed. And the question is, have you thought of replacing the daily sheets with some kind of digital form that can push the information directly into the geodatabase?
Yes, so I did speak to two companies that are quite new, and honestly, I've seen these new companies being created in the last 3 years to manage this information. But the only problem I had was the integration of that data with our SQL database. Most of these companies are using very, very new technologies like non-SQL databases, and we are still using SQL technologies. So that was my only problem, the integration of data.
Excellent. Hey, maybe another quick question to you, Fernando. Are you automating the process of updating the data to AGO at all? Are you taking advantage of any Python scripting or any other automation function?
Yes, so for the second scenario, for the Imago dashboard, it is all scheduled through the Jupyter notebook in ESRI. For the first one, for the drilling dashboard, we created our own Python, and we just run it as an SQL job.
Okay, perfect. All right, Matt, real quick, little quick rally questions here. And we're getting a lot of these questions, and I think they're all related to the field maps and say survey 1, 2, 3. Will field maps replace survey 1, 2, 3? And can you bring survey 1, 2, 3 forms into field maps?
Yeah, and I can tackle a couple of these questions. So one, we aren't planning on we aren't planning on getting rid of survey 1, 2, 3. That will always be its own solution because there's a need for more form-based data collection, where the map might not be the most critical component of it. And there's an extensive amount of smart form features in survey 1, 2, 3 that come with the tools that it's built on top of that. We're not going to replace it with field maps, is what I would say. And in terms of like importing survey 1, 2, 3 forms into field maps, that isn't available. You would have to reconstruct those forms in field maps.
Okay, thanks. And I apologize, Matt, there's a lot of other questions that I'd love to get to, but again, we'll summarize those, compile them, and send them off to everyone. But I think it's best we go ahead and wrap up here. Any questions on this webinar, or any question related to ESRI's ArcGIS system related to mining? You're welcome to send your questions, inquiries to me, Pete Will, at that email address, and I'll make sure to contact you back. And Matt Ballard and Fernando would be happy to take questions as well, so their contact information is here as well. I did want to make you aware that there's a upcoming ESRI virtual UC, or virtual again this year, so please attend. We'll have a special interest group for mining on Thursday. There is a short webinar following this presentation, and the last things on there are just links to our mug group and how to get copies or recordings of these webinars. So with that, I want to thank Fernando, Matt Ballard, especially Sarah Powell for being in the background and organizing this webinar. Everyone for attending, and please be safe in everything you do. Thank you very much.